Good afternoon, everyone, and welcome to a new session of Archive Online Academy, the public training program of the Digital Center of Fondazione Giorgio Cini, dedicated to the digital humanities and digital conservation and enhancement of cultural heritage. Today is the third and last lesson of this course named AI and Heritage, Practical Skills for Extracting Information from Historical Documents, led by the team of the DH Lab of EPFL. And before giving the floor to Paul, I would like to remember everyone that may be interested in receiving the certificate of attendance of the course to follow the instructions that we will give you in the chat. And you can use the chat also for questions or consideration, or you can also raise your hands. And thank you again for being here and enjoy the lesson.
Okay, thank you, Irene. I will briefly introduce today's lecture to you before giving the floor to Isabella, who's going to delve into one of the topics in greater detail. But as I've done for the first two lectures, I thought we could start with a brief summary of what it is that we have been doing, why, and where this is going. Can you all see my screen? I think it might. Yeah, okay. All good? Okay, thank you. So, so the core idea behind this series of lectures and workshops was to show you through a succession of case studies what AI can do in the context of historical archives. And we have chosen as a starting point, or as an example, the photo collection of the Fondazione Cini, of course, which you can see here on the left, this massive archive of 300,000 images, and on the right, what typical examples look like. So the different steps of what you can think of as a pipeline cover different bits that pertain to the document. I have summarized them here, and I think you might be familiar with the figure by now, but the original document is on the left, and then the first step would be to divide what relates to an image and what relates to text. This is what we have done in the first session, training neural networks to identify the artwork, extracting it automatically, and then segmenting it. The second half of that process relates to the text, which is located at the top of the document. And this is what we have done a couple of days ago, where we have learned all of the different techniques and strategies, let's say, in which AI can be used to not only detect where text is, but how to segment these regions, extract the text in itself by detecting the characters, correcting it, and then storing it into a database. This is the section that you see at the top. For today's lecture, arguably the most exciting one, if you ask me, we're going to actually look at what we can do once we have managed to extract that. And this is something that obviously might motivate you to use AI in archives. Is what does it bring to historical research? How can you leverage the potential of AI to answer questions that otherwise would not be possible to tackle? And they might be things as different as the geography of your archive, its time distribution, some internal statistics, etc., etc., etc. This obviously depends on what kind of source material you have. So a key challenge here is how we go from the extracted text to structured information. And this is particularly important because the extracted text might be a bit imprecise sometimes because the network might do some tiny mistakes. It might also be uncontextualized at this stage. And a challenge might be, for example, to detect that this bit of text corresponds to one artist. And as such, this is how you can start to make some form of statistics and understanding of what is contained in your archive. So very brief summary, this is the image extraction bit. The first session taught us how to extract the separate images. The second session taught us how to construct the first steps of a database that would be linked to each of those images using text extraction. And yes, now we want to contextualize this. So this is where I leave the floor to Isabella, who's going to take you through the different steps, methods, strategies, and problems that come with aligning text onto a database, especially in the context of such an art historical archive. And then in the second half of the lecture, I will detail perhaps a bit more the technical things, the technical solutions that we can leverage to enrich this text, to create this database. But first, Isabella.
Many thanks, Paul. So I try to share my screen and we start with this presentation up. I hope that all it's working. Yes, so a brief recap to I'm sorry, about the last things that you have seen in the other two lessons, so last weeks. Essentially, as you probably have understood, so the approaches for extracting information from historical documents starts in a granular way from the layout of the document, so from the layout of images, and then they go through a more granular level. That's the level of the contents, of course. So the contents, it means that we want to read essentially and transcribe potentially what is written in the historical documents. But first we need to segment the image that you have scanned, so the image digital, that's the digital artifacts of the historical documents, and potentially that step, it's very important for categorize elements that you see on it. You already have seen the examples of, for example, yes, printed text in which we have ornaments, and we are potentially interested only in this type of elements, or titles, or also on the right side of my screen, in the Cini photo library cardboards, we need to separate the background from the image, from the metadata, or all other informations that are on the page. That's the first part of our work. It's very complex. It depends a lot on the cases that we have, as you see last week, thanks to the Sven presentation. Because as you can see, for example, there's also cases in which it's very huge task define what's the main text on an image, what are the commentaries, what are notes in the margins, and so on. But that's absolutely important to do. Also because we want to keep the order of the text, in the sense that we want to are able to, when we are authorized the page, we want to be able to recognize exactly what's the order of the characters that we need to classify. And we start the same time, so we start very soon this approach, specifically on the Cini dataset in 2015, so very soon. EPFL was one of the main university in Europe that tried to apply this type of techniques that was quite common in computer scientists approaches to cultural heritage artifacts. And we also organize a lot of workshops with curators and conservators, for example, at the in the national libraries, as at the BNF, Bibliothèque Nationale de France in Paris, for example, for training specialists to annotate and to segment parts of documents. In this case, for example, you see this in this slide, parts of manuscripts, but also parts of photographs in photo collections, in which we need to identify where there's text, where there's image, but also other type of items, and we need to provide categories for each one. So we want to describe that there's text and description, but there's also visual elements. We can go further to other type of documents, as for example, census documents. This could be very interesting because segmenting census registers is something quite simple for now. It was not so easy 10 years ago, but it's a very key step in definition for defining classes for each columns. For example, through the segmentation of these registers of census data, we are able to define that in the first column we are the identifiers of the owners, and then the name of the owners in the second column, and then the third I don't know what else, so the functions and so on. So this is something that is now the state of the art. And something more complex that we don't see during this course in our Cini appointment, but it's quite interesting too, is try to apply the segmentation and annotation to the cartographic elements. So that's something also possible, and it's also very useful if you have project based on cartography or historical cartography. That's very that has a big potential for extracting information. Just for the history, all these techniques starting more or less, as I've said, around 2014, 2015, and EPFL was one of the main partners of the main project at that time, the main European project at that time, the consortium READ, that was the initiator of the large platform available today, transcribers. And all these techniques that you have seen and that Paul and Sven and me, we are illustrating here, were at the base of the work done by Transcribers Consortium, and recognizing lines, recognizing text, recognizing parts of the layouts of the document is now thanks to these advancements, is now state of the art that permits to have this type of tools. Now, for the Cini case, as we already have explained, in 2016 we start to digitize a part of the photo library of the Cini Foundation, and we worked with these cardboards, so this Cini schedoni, for which essentially we need to extract the images, and then part of the text. That's quite common problem in photo libraries. Of course, it's very, very common, but also in other type of cultural heritage collection or archival resources. First, detect, of course, the general layout, and you have already seen this last week. But then specifically approaching the problem of extracting the text. Concerning the text, there are two levels of extraction. First is try to labeling the information by category. And the second is try to reading the context. So that's something that we already mentioned. In these cases, you are seeing what happens when we try to authorize the contents, so the read, essentially the transcription, produces a double of the transcription of the text. But of course, there's also important try to label the elements, because we want that the Londra word corresponds the fact that it's an information to keep us city. Same thing for Carlo Maratta. Carlo Maratta, we need to label it as an author. Same for British Museum. British Museum is an institution, and we want to keep this record in this class of elements. Okay, so there are two elements: transcribe text and label the text. Through these methods for the Cini cardboards, we have to say that about only 3% of the metadata has not been acquired, so it's very few. We apply some techniques that we'll show just now. What is the OCR? You have already seen. What's the optical character recognition? So essentially, it's a technology able to convert images of text into machine-readable text. It's quite accurate for modern standardized documents, of course. There's some challenges still in terms of categorization of elements, or for the reading in the cases of abbreviation, for example, or not known or not or uncode characters, but essentially there's no encounter a lot of problems. Completely different is the HTR recognition. So just for giving you some example, HTR is essentially based on the handwritten text recognition, and of course it's a huge task in terms of recognition, because it depends on the training that we have done through annotations, essentially. So it's strictly dependent on the accuracy of the annotation and on the volume of annotation too. In the case of OCR, what are the problems that we can have? Problem of inconsistency, because even natively, documents have no standardized spelling. Okay, that's something that it's not directly depending on the accuracy of the OCR, but already because in the data, at the origin of the data, we see different spelling of the same words. Some examples: Michelangelo can be Michelagnolo, or Tintoretto, Tentoretto, or Rialto, Rialto with H. So there's a lot of cases in history, right, like this. In our experience, we have seen that, of course, in authorship, so name entities reconducting to persons, is present, but less than, for example, place names. In place names, we have a huge amount of this type of variations. And we have to see that before the 19th century, it's also true that the orthographs are not already defined, so were not already stable, and that's important to highlight. So the algorithms cannot, in the first step of authorization, we cannot infer that there's the same person, that Michelangelo and Michelagnolo are the same person. But we need to do this inference. So we need to do this realignment for building our database. Then a second problem that is more related to the concept of what is an entity is the fact that in the documents we can have not only name entities as the first name or the family names or place names, but also categories. For example, and that's the case of the Cini cardboard, in the field of the authorship, we can have something like Venetian school or 16th century or Flemish context and so on. So there are not name entities, but we want to keep trace of them. Okay. There's also other problems. Maybe we have capitalized terms or we have numerals. And there's another aspects that we have to take in account when we try to realign some elements like authors, for example, or even place names in a knowledge, on a knowledge base. Yeah, we have already said this. For example, in that slide, we have Pittore Siciliano, secolo XV. So how we can disambiguate this, how we can treat these data. Because in some cases, they are few, so they are not impacting our analysis, but in other cases, they can be a lot. So we need to have some heuristics for treat. In these cases, century, 15th century, like in this one, or location unknown, or nothing new. Okay. Some insights about methodological approaches that we can apply. Of course, we can have both manual or automated corrections. It depends a little bit on the entities of the problems. So depends on the quantity, essentially, of the cases. Of course, that's strictly related to the research project that you are doing. Just for giving you an example, when we manage census data, we are talking about 30,000 records or 50,000 records. When we are talking about place names that we extract from maps, only from one maps, for example, we can have thousands place names. Okay, so what's the limit for manual approach, and when starts the automated correction? So that's a very interesting question. In my opinion, it depends a little bit, of course, on your time or the need of the accuracy that you have for treating your data sets. For us, we are familiar with data sets that count thousands and thousands of data, and for this, if we lost 10%, so that it means I don't know, thousands results, is not really impacting the research. But of course, that's something that you have to take in account. What it means, do the correction, and how they can impact your work if you don't go through a good quality in the accuracy of your data. So we need to normalize, what we call to normalize all these variants of spellings in authors, for example, or place names. And we can do this through some specific approaches. Another example, we can have essentially in one hand results extraction of Tintoretto, Tintoretto, Tintoretta, or more interesting, Jacopo Robusti or Jacopo Robusti detto il Tintoretto. That's from the OCR results. And then on the other side, we need to realign on the Tintoretto entity. Okay. And it's at that point that we need to have a matrix. That it means that we need to define what is the correct distance that we want between the good results that we expect and the messy results, or not messy, but different results that we have in the OCR. And essentially, there are many distances that we can take in account. There are many methods. Today we present to you the Levenstein distance. That's something that Paul go present after too. And the fact that that's one of the possibility. That's not the main one. For us, in some cases, quite good, at least at the beginning, for identifying what are the problems in this realignment, what are the cases, problematic cases in the realignment process. But they can have also, we can have also other ratio for doing it. A concrete example, again on Tintoretto. So the Levenstein essentially tried to detect the similarity in single character edits. Okay. So that's the way, because it's very good metric for word that looks quite similar to that one that we want to realign, but it's very bad for example, cases like Jacopo Robusti detto il Tintoretto, for which we expect a good result, but we don't have it, of course. There's also other techniques, essentially based on the natural language processing, and they are based on other kind of match, like, for example, something more at the level of the word, and what we call the token, and less at the level of the characters. And if we combine both, and if we analyze both, we see that second methodologies could be very good in some cases. And that's the case of Jacopo Robusti detto il Tintoretto, because in that string we have Tintoretto, so we repeat the word Tintoretto, and that's permit to have a nice score comparing to the Levenstein distance. So the question is when we need to use each. Again, no truth about, in the sense that it depends a lot of your project, of your data sets, but of course it depends a little bit of what are the type of results that you want to match. If we are talking about character by character comparison, maybe the Levenstein distance could be more interesting. But if you have string longer, maybe combining 2 or 3 words or sentences, for example, or strings with different word orders, probably the token approach will be more interesting. So it depends a little bit on the nature of your data in entry and what type of normalization you need for the realignment at the end. Of course, we need to be aware that this work of refinement impact the historical research, because if you produce error at the beginning, of course, these errors have been propagating into databases, but also in statistical analysis, historical interpretations, and so on. That's important to understand, of course, and that's important to take in account. And that's why when we publish a data set, we take care to produce all the documentation about the methods for extracting data, methods for normalizing results, methods for building essentially the data sets, and what we have in it and what we cannot have in it. And a specific place take the explanation about the accuracy of the data extraction. Now the second part of the work, so because we have extract through the OCR information, we are trying to realign through different heuristics for normalizing these names that at the beginnings presents orthographic variations, and we have now potentially several columns in our data sets in which we have the original transcription, and then we have the normalization, and then we need to realign our normalization on an authoritative database. What are the authoritative database? What are the what we can also call knowledge database, and why we need it? There are a lot of databases containing categories, elements, specifically for historical research. Today we just see that they are more interesting in the case of art historical data sets, but there's a lot of other types. For example, for just for citing something else, for example, place names. and not only contemporary place names, but also place names in antiquity. There are several authoritative databases. There are also specific databases for historical professions, for example, or there are historical databases for other type of contents in histories, like editions and publishers and editors. So the panorama about the authoritative list it's very huge. Today, Paul will present how you can realign on the Getty Ulan list, that one of the main database for standardized authors, so for standardized artists, but not only also geographic names. There's also the VF authoritative database. That's it's a very big database in which you have so it's a list of lists in the sense that it's a database in which you can refine all the referential of an author, for example, Tintoretto, that with the ID, so with the identifier in the network of national libraries in France, in the network of national libraries in Germany, in the network of alliances for art history, and so on. So it's a very, very meta authoritative database, very important. Then, of course, the Library of Congress. That's particularly interesting because there are also in it there's also the cross-language fields that could be very useful, because in some cases we do research in data or information that natively are in another language, for example, from the East or of Europe, or from, I don't know, something specific on Africa or other type of data sets. So that's why we need to realign potentially on authoritative, okay, I keep it, database that permits this cross-language feature. And then, of course, Wikidata. Wikidata, it's also important. It's not Wikipedia, Wikidata. There still we have definitely a cross-language data sets of categories, and a lot of more elements about the biography of each, for example, artist, but also works of art produced, but also place names, and so it's very, very huge in terms of type of data. An example about Tintoretto, again, matching with the Ulan ID, we can, of course, have more metadata. So we essentially, through the realignment on the authoritative identification, we can enrich our data, because we can, for example, access to all the variants of the name. And this is particularly important for the reason that we mentioned before, because in some cases, extracting data, we have Tintoretto, but in others, we can have Jacopo Robusti, or Jacopo Robusti called Tintoretto, or I don't know what else, Jacopo Comini, okay, even. So that's why realigning on Wikidata is particularly interesting. We can also keep all data concerning pupils or followers or sources in which his name is mentioned, works of art in collections. So, for example, if you have to do a cartography about the spread of the works of art of Tintoretto, you can through this realignment. Or how many times he's cited through literature, or where it has been, he has been exposed in exhibition, or you see, so a lot of files and categories for this entity. Okay, last thing to do, is to say that probably not all the name entities that we have extracted for the Chini case, you see this percentage, so we have a realigned 73 about percents of the names on the Getty Union list. Why this? Essentially because not only because there are a lot of anonymous, for example, that we cannot realign, or the unknown, or the known empty field, so null field, but also because there are a lot of also of master of, and etc. So there's a complex grammar in the description of the authorship, and that's particularly also interesting, because see this, it means see what are the practice of conservator and curator in attributing the authorship to a visual item. That's particularly interesting too in terms of research. So take a look to this 27 that you cannot realign, and see why, and see what are the differences between all these records. Okay, and maybe I don't know if there are something to say more thanks to the poll contribution, but that's also another part. So it's the dark side of the of the moon of the data sets that could be also taken in consideration when we try to understand what is the corpus that we are analyzing. Okay, maybe I give the floor to Paul for the following steps. Do you have some questions on this first part?
There is a question in the chat from Alessandra, who asks, in realigning the name entities, do you deal also with alignment between different languages for people, town, etc.?
Yeah, of course. Yes, absolutely. Yeah, of course, because there are a lot of painters, for example, coming from France or Germany or other else, and there's no policy for the conservators for transcribing their name in Italian or natively in French. So, of course, yes, we did.
I have a question.
Yeah.
So at first you talked about the algorithm. You said that unfortunately there weren't any standard in this algorithm. That's the reason why sometimes they struggled to recognize properly words or text. So my question is, if indeed the algorithms are quite different. Is it impossible, between brackets, infinite, to have a common database and also, I won't say no errors, but as long as this algorithm exists, and if they are not all the same with the same structure and the same yes, the same standards. So as long as this doesn't exist, is it quite chimeric to think about having an only database without any errors?
Mm-hmm. Okay, I tried to interpret your question. Sabine, you are asking about the fact that when we are not capable to extract properly some results, we need to have to stock these results in some parts and to present them too in the data sets. Is that the so how we can keep trace of the errors? That's the question.
The question was, as every algorithm you said is different, so has different structure and different ways to analyze data, text and images, is it quite impossible to have results that doesn't contain any errors due to the fact that the algorithms are different and haven't the same structure, you said?
But yes, the algorithm, probably you are talking about this part of the discourse in which we try to define that there are, no, it's after, is there, when we have many methods. And so having many methods, we have many metrics essentially for treat the data, and to each methods corresponds code essentially, so an algorithm in this respect. Okay. Yeah, but they so it's not completely true that they are not standardized. So when we talk about the Levenstein distance, we know which is the matrix of this Levenstein distance. So it's known. It's not a magic receipt and hidden. It's not that case. So the code for producing the Levenstein distance is public, so you can access it. And when we publish a data set, we publish also the code through which we have normalized, for example, the results. So it's not hidden at all. Not for, in the case of Levenstein, so not for the Levenstein, for example, not for the natural language processing methods that are also well known for their algorithmic parts, if you want. Concerning the errors, I never seen data sets without errors. Then what it means errors? If errors, it means that the OCR that you have done, it's messy and it's not good enough for transcribing or for do that each word corresponds to a word known. That's also possible. And then, yes, you try to refine it, to clean your data sets. But of course, cleaning data, it means that you need to do choices, and you need to publish and to show what are the choices that you have done. So, for example, just for taking too abstract to talk like this, but for example, in this page, there on up on left you have Londra, but for the OCR, that's are just character L O N together. The separated R, separated A, so A. And you need to keep them together for read Londra. Okay. If you don't do this, if you are not capable to define that's character or Londra, you can define this an error of reading this text from the OCR. But there's not an error in the sense, yes, in the final sense. Finally, you have Londra. In any case, when you publish a data set, you have to declare your accuracy in the data. So in theory, you need to define for how many data you have been capable to have this normalization and how many data you have lost potentially and why you lost it. So yeah, I don't know if I answered to your question, but in any case, if you are interested on this aspect, you can also contact me after the lesson today.
Okay, thank you.
There's another question in the chat. Concerning the realignment over language, is there a way to align the results, but still have some indication of what the source material language was? I.e., a certain document chose to use the French rather than the Italian spelling.
Mm-hmm. Yeah, but still have some indication of what the source material language was. Yeah, that's an interesting question. We can say that in the data sets, so if you are treating the data set in Italian, but that's not really complicated for names, I think. That's more complicated for professions, for example, for ancient professions. Because my opinion, it's always better to keep the data sets and to keep the data and the realignment on the original spelling of the documents. Okay, that's my answer. But it's true that in some cases you need to have this open spelling on the other languages, because maybe that painter is not Italian at all, even if it's extracted from the Chin dataset, but it's French. So we need to realign also, or to suggest that for the same name, we have two options. So we have, I don't have a fresh sample now, but so you can. It depends a little bit on the output of your research. For example, we are building, as probably we have, and not in this triptych of lessons, but we presented an interface that we are doing on, we are building on Venice. In that case, in the interface, you can search for a Venetian, for example, Foscari, and you need to maybe see that this people was, I don't know, a lawyer, okay, an avvocato. In that case, it will be interesting to have both languages, in fact, in the interface, because it permits to someone from an Italian context to understand that was an avvocato, and for someone that is not so proficient in Italian to understand that was a lawyer. So because professions are very specific, and maybe it could be interesting to have this multilingual layers. But of course, my opinion is to keep the original language of the documents. I don't know what do you think, Paul, because it's true that you have concretely see these cases.
Well, if the question was on the technical aspect of it more than the organization of the research or the outcome, etc., then the answer is absolutely yes, you can. In fact, I will show you how in a minute.
Okay.
And perhaps this is a good transition for my section, unless there's any other question for Isabella. Okay, well, so let me briefly extend on what Isabella presented, and how concretely we can align text. I'm going to show you, well, what is meant by the different metrics that she mentioned. Of course, the main challenge is to align whatever you get from your OCR or your automatic text detection to some kind of truth that is either grammatically correct or that is at least mentioned somewhere else. So it's the idea of reducing the number of possibilities to a fixed, limited set of choices for better comprehension. Typical example is something that we have seen last week when extracting the text. In the case of our pipeline here, the Chini cardboards, there's a collection name. And of course, typically collections are fixed. They can be either from specific museums or collectors or photographic archives, but we know where they are. On the left, I've shown you all of the
I'm sorry.
Yes.
Are you showing anything? Yes.
Oh,
Okay.
you can see. Can you see my slides?
Not really. So your screen is freezing. I don't know why. I'm not sure that it's only for me or also for now. It's okay, but when you are going to the
full screen,
I don't know for
it stopped. Okay.
Could the others see the screen? Probably it's flashing. Yeah.
Okay, this is slightly worrying. Okay, let me try something else. Just showing my entire desktop. Is it better now? Or same problem?
Yeah, good.
Okay, good, great. So as I was saying, a typical example is when you've got different variations as they come out of the OCR. And many of you last week asked, what happens if there's a mistake? What happens if the detection is not perfect? Do we retrain? Do we post-process it? Well, typically in such a case, when you have an idea of what you expect it to be, or one of the values it can be, then you can avoid retraining and simply do some post-processing. So this collection in the Chini, this sub-collection of the Chini, the Corpus Gernsheim, is a collection of about 20,000 images, so obviously quite significant. And as you can see on the left, well, the OCR sometimes has some problems. So G's might be swapped with 6, C might be swapped with E, etc. Not to mention that the archivists, and this is where we move into the more analog problems, if you wish, of an archive, they don't always follow the same naming convention. And Corpus Gernsheim sometimes is described as just Gernsheim, or CG, or some kind of abbreviation. So what we want to do in the first step is to identify those variations, and then from this subset, detect automatically which it could be. And this is where our distant metrics, as we say, come into play. So a distant metric is something that takes 2 strings of text or set of characters and compares them to output a number. And the value of the number tells you how close the two things are. So if you take a look at the bottom half of my screen, I've given you Ganshheim, which is the thing we want to align to, and then two typical variations that might come from the OCR. One where the G is swapped for a 6, and one where there's a couple of letters that are slightly wrong. So what we want to do is compare each of those lines to the original, to the first one. Isabella mentioned the Levenshtein distance, and it's a very common one that you might be using if you end up coding to manipulate some archives. It's very versatile, and it simply measures the number of edits or changes that you need to make to go from one string to the other. An edit can be either a letter being removed, a letter being added, or a letter being replaced. So very versatile. In the case of archives, I've also found that another metric distance is quite good, quite fitting, is the Gestalt pattern distance, also known as the Radcliffe-Obus help from the two scientists who devised it. And it is quite good at picking up when the detected word is almost perfectly good, but for some reason one or two letters have been swapped, but the core of it is good. And the way it works is it looks at the longest common substring. I will not go into more details now because this is perhaps a bit beyond the scope of our lecture, but this is just to tell you that you can choose different solutions, and this is something that you can play with as well, depending on your scenario. Okay, so bottom line being, through these distance functions or metric distances, you can go from the noisy input of the OCR to one final thing that you're happy with, and that is sort of manual standardization. Not manual in the sense that you automatically do it, but you come up with this middle layer of variations. Obviously, if you want to align artists or things for which you have ground truth, this is a bit more difficult because you cannot manually enter the ground truth for each. So this is where we turn our attention to knowledge bases, as Isabella said. And in art history, there's a few. The two I'm going to be focusing on shortly are the Getty Ulan, which is this union of artist names, manually crafted by leading curators and art historians. It's an absolutely massive data set. And then the Wikidata, which is more collaborative, but has other things that the Getty doesn't, typically artworks themselves or finer fields. The way we do this is first by getting the data. And I'm just going to briefly introduce what it means to get the data in such contexts. There are such big databases that downloading them can be a bit difficult, especially in the case of Wikidata, which not only has artists, as you know, but a bazillion other things from city to historical events, famous people, etc., etc. So what we do is we first get a subset of that, which we download, and then compare our results to what we have downloaded as a subset of Wikidata. And this is the structure which I'm showing you here. It's called a SPARQL or Sparkle query. It's a form of query language to ask databases to do things. I'm just showing this here because obviously we're not going to go into detail. It's a bit outside of what we do, but to show you what sort of things you need to expect if you want to download databases. So in this case, the structure is combining different attributes from the database, it being a human, it being an artist, and artist being the occupation of the human. This is the structure you see here, to extract a subset that is of interest to you. Going back to the question that was asked by one of you on the language, one of the things you can extract here is the language of the specific artist. So, for example, Tintoretto is also known as Tintoret in French, and you might want to ask your database, whether Wikipedia or Ulan, if you want the French name, the Italian name, both, etc. But then the information is kept, so you can access that and note that, oh, you matched Tintoret with the French name of Tintoretto. Good to mix and match different databases, because even though they have some differences in numbers, they also have different uses. So typically, if you take Rafael here, what Wikidata is quite good at keeping track of is the places that the artist has spent some time in, which then you can use to map those movements of artists, which is what you see on the right. This is sort of the summary of the grand pipeline of how we align names. And we're not going to do this later because it's a bit too complicated and too nuanced to do in 1 hour. But basically, you start from your OCR input, and then you compare it to perfect matches, which is what we're going to be doing. You might want to isolate cases where, like Isabella said, the archivist might have written, this is only 17th century, we don't know more. Obviously, you don't want to match that. You might want to get rid of things like school of XYZ, student of XYZ, which will not be matched. And then you start again, perhaps loosening the constraints as you go. Always keeping an eye, of course, on how this is done, because as was also mentioned in the discussion, there is no one perfect solution, and algorithms, although powerful, might bring some imprecisions or biases which you need to keep in mind. Okay, and then the final thing before we move on is, so we have now covered how you go from this raw text from the cardboard to align names with different spellings, maybe in different languages, align to other databases that tell you other things, dates, that sort of thing. But we might be interested in the spatial nature of our archive. No matter on what you work, I'm guessing there might be some things to plot here in terms of geography, whether it's where the documents come from or what it is they represent. So just as a quick teaser, or rather introduction to what we can do in this case, well, the process is the same. You start from your text, the one that you get from the OCR, the one that is automatically extracted, and you want to map it to an actual physical thing. Just like we have matched the string Tintoretto with the painter Tintoretto, we can match the string Art Gallery of South Australia to an actual museum, and actual coordinates. The way we do this, and we're going to be playing with this in just a minute, is to query this to OpenStreetMap, which is another openly accessible database, free to use and made by the community. This process of going from a string of text to actual coordinates is called geocoding. So for example, I'm just typing here Art Gallery of South Australia, which was written on the cardboard and extracted automatically by the network, and I end up at this correct museum. The good thing with that is that there is no just one way of describing a place, and people who created OpenStreetMap know this. So if you query those different things, Art Gallery of South Australia, Gallery of Adelaide, etc., they will all somehow match. So this alleviates the need to do some manual transformation of your input data. Okay, so this was the end of the first half of the lecture. Is there any question on all of those dimensions that we have mentioned? The text alignment, the external database, the spatial positioning, etc. No. Okay, well, of course, if you have any questions, don't hesitate to bring them up at any time. So let's move on to our final workshop. So this is, as you know it by now, the drill. You go on Google Drive. I'm going to copy and paste the thing in a second, on which you will find different files, much lighter than before. So this should be quite fast, not as complicated with many folders, etc. And in it, you will find a notebook where you can follow instructions that will take you through all possible steps and all different instructions that we have covered today. So let me just go and get you the link. There we go. What you should be doing is downloading it and then again putting it in your drive so that you can access it through the notebook. So once you have done that, you can double click on the notebook itself. And again, this will open in Colab. That you can then click connect on the right. And you're good to go. So the structure of the notebook is relatively lighter than usual. First one is about how we extract how we align our names that we extracted last time with this Getty database. The second one would be how we extract the actual position in space, the geographical coordinates of people's birthplaces. And then in part 4, some basics on how to plot and do some statistics, which might be of interest. And then for those of you who are very keen, there's a tiny bit harder question at the end to put everything together and see what we can do. But of course, this is only if you get so far. Okay, so what I suggest we do is, unless there's any question right now on downloading / opening the notebook. Right. So what we can do is perhaps reconvene in about 10 minutes so that you can read and note for yourselves. Just as a reminder, to run things, you can just click on the little play button here. One cell after the other. Okay, don't hesitate if you have any questions. Okay. Is there any pressing question before I simply walk through the cells with you? No? Okay. So let's get started. So the first two cells are nothing that you haven't seen before. It's just simply about importing the right modules so that we can access the contents that you have downloaded and that we can also use the different libraries. The second cell is about using the results of what we have done last week. Remember this progressive extraction of different information and this creation of a database. So to do that, we simply use the function read CSV, give it our path, and then importantly, we need to specify that it's a CSV, but the separator is a semicolon. And the reason that is because some of the cells will contain commas, typically in artwork names or in artist names, and we don't want to mess the structure because of those commas. So at this stage, this data frame looks like this. And then you might recognize it from last time. It's got all the information from the cardboard. Okay, then on to aligning this with the Getty database. So first, we need to open that Getty database, and luckily, I already pre-downloaded the results from the Getty website. I've reformatted it for you so that it's super easy, and we open it just the same way, like that. So we read CSV, we also add the separator, and it looks like that. I've taken a sample because, as I've told you, the whole database is 500,000 entries or artists. I've just taken about 1%. But as you can see, there's a lot of information, and I haven't stored or saved all of it. I've just kept the name, some kind of identifier that points to a web page. And this web page is what I have shown you earlier. So it contains name variations, biographical details, that sort of thing. Also other forms of metadata, the gender, the nationality, a label, birth and death. All of that is found on the website. It's a structured version. As a side note, for those of you who might be interested in using this data, the Getty exports it as an XML. So the things that we have studied last session, converting an XML file into a data structure, will be very useful to you because it's exactly the same structure with those nested dictionaries, etc. This is actually how I created it. Okay, so the point is now to align what we have extracted, which looks like this, with what the Getty is giving us, which looks like this. And what we can do is simply use the fact that it's got an artist name, the cardboards, that might be contained in the Getty. So this is what we're going to be doing. We're just going to be looking at first for exact matches. And the way we do this in Pandas is actually contained in this line. Inside the Getty database, we're going to look for rows or entries whose label is exactly equal to the name we have in the Chini cardboard. I have just removed the capitals, the uppercase, because in the Getty it's not with capitals, but apart from that, exact matches. If there is an exact match in a single one, we store it and we're happy. So this is what this cell does. And this is what it looks like at this stage, right? We've got our Chini cardboard names and their Getty version, standardized. No big surprise because they're exact matches, so we're happy. But at this stage, some entries are still missing. For example, 9th century, is not happy. Jean-Baptiste Oudry is not happy either, and Andrea Del Sarto isn't happy. So we've got different solutions, and I've prioritized simplicity in this case because we don't have much time, and because it might not be the most interesting to you. But the first thing would be simply to manually add that to our list, and this can be useful, for example, in the case of 9th century, which is something that will come over and over again if you're dealing with certain cardboards. So how do we do that? Well, we're going to modify our dictionary. So this is a Python dictionary. Remember, we talked about those later, last session, and therefore we can add a key value thing. We're going to be doing that in a second. Right. This would be for the second case. But for the first case, Jean-Baptiste Oudry, those of you who speak French might be understanding that this is actually an abbreviation of Jean-Baptiste Oudry, the actual artist name, that the archivist simply wrote as Jean-Baptiste. So we can check that, this intuition. And indeed, we find that in the Getty, there is Jean-Baptiste Oudry. So it is about shortening the name. So in this case, we can simply manually correct this abbreviation by doing that. And the same thing for Andrea Del Sarto. So we do that. And then after these two manual corrections, this is what our dictionary looks like. It's basically the same, but with two new entries. Again, we might want to do the same thing for our more generic collection-specific descriptors like 9th century or 15th century Veneto. And let's assume that we want to translate them into English, for example, for some sharing purposes. This is how we manually transform our dictionary. We say that the value at this key is this new value. Okay. Now there are ways, and this was the point of the question, that we can automate, through which we can automate this process, typically extracting this as being the 9th century and then automatically converting that. Okay, so using this, let's call it the Cini to Getty correspondence dictionary, we can do our match. And we're going to do this in two steps. First one is by creating a standardized or normalized, as Isabella said, name, which is, you can think of it as the go-to most neutral name that is most likely to be found in the Getty. That's the first step. And then we're going to look for that name, that standardized name, into the Getty data frame. So step one, we map it and we put this in a new column called standard name. And then step two, we merge that using the fact that the standard name is actually the Getty name. So we can run this. And now if things go well, we have our usual data. We have our standard name here. And we've got a bunch of new columns that do come from the Getty. So there's an ULAN, this ID, there's some nationality, birth, death, etc. So in those few lines, we have managed to add some things regarding the oath of birth, death, etc. Okay, let's say that we can skip, that doesn't matter. Okay, any questions on that? No, everyone's happy with this? Okay. Moving on to part 3, geographical alignment. So what we're going to be doing here is adding not only just biographical information and dates of birth and death, but also places of birth and death, the cities, if they are known. And the way we do this is by turning our attention to Wikidata, that other database. Again, I've prepared for you a Wikipedia database that is ready with some name, some birth city, some death city. And the idea will be first to sort of match that onto our data set, our little 12 entries from the Gini, so that we also have the birth and death places. That's the first step. And then the second step would be to extract the geographical coordinates that correspond to those places using geocoding, the thing we have introduced in the lecture. So have a look at this part 3. There's a question here. Why do you merge with the Gini data with Wikidata and not directly with ULAN? Well, actually, we are merging with ULAN. This is where this name comes from. So if you look at the data, let me show you. This Wikidata is actually containing the name in the Getty. I've just shortened and simplified the data frame so that you only have the Getty name and the wiki data places. But yes, basically the two are aligned together, and then those two aligned together are going to be aligned back with the Gini. And then Erin asked, is querying Wikidata similar to querying ULAN? Is the output also an XML file? That really depends on how you query it. If you can query Wikidata, Wikidata. Like this, if you go on query.wikidata.org, this is how you query Wikidata. And then once you have output something, you can choose which file you want it as. Typically, you can have it as a JSON or as a CSV. And I don't remember if you can have it as an XML. It's possible, but XML is very good in cases where you've got relationships between different items, which in the case of a dedicated art history database like ULAN, where you want typically to keep X was a student of Y, etc. This is the standard way. And I don't know if Wikidata is that extensive when it comes to relationship between entries. I hope that answers your question. Okay, so if there's no remarks or comments, I can perhaps go through with you this third part on the geographical alignment. So as I presented before before you looked at it, we turn our attention to the Wikidata data frame, which looks like this. It's got the Getty name and it's got birth and death cities. And the way we do this is exactly the same as before. We merge the two data frames, the two tables. We can merge them very easily because they all share the ULAN name, so we can merge that on author ULAN label. You might want to keep an eye on how you do the merge. So if we inspect it, it looks like this with our 14 entries. And then many of them have now got a birth and a death city. Some of them do not, and that is because they are not contained in the Getty database. So if we are not careful about this, this is what it looks like, and it's much shorter. We have gotten rid of 5 entries which are not found in the Getty. So do keep in mind.
I have a question.
Yes.
So in case, for instance, during the 13th or 12th century, some painters weren't registered. So some painters have maybe sometimes different birth dates and different death dates. So in this case, how is it possible to merge the data or to find some data online which is quite accurate?
Right. So I mean, the two parts of your question are to be kept separate. There's the how do we align this, and this is the same process. It's technically speaking, it's the same process. We just have our input, and then we come and add some form of external knowledge. But the core of your question is on that second half, is how does this external database keep track of those possible uncertain dates or those ranges of dates, etc. This is all dependent on that knowledge base. So for example, the Getty, I think, keeps a question mark after the date to indicate that it's imprecise, uncertain. I know of other knowledge bases that keep a range. Typically, if it's a century, they have 1200 to 1300, etc. So this is all dependent on the external source. And the problem now becomes, what do you want to do with this information, with this uncertainty? Do you want to keep it because we don't want to pretend we know when that painter was born when we actually don't know? Do you want to keep the painter away and remove it from your data set? Or do you want to get an average if you're looking for some kind of average large scale metrics? This is really dependent on your case study.
Okay, thank you.
Okay, so yes, so now we have added a birth and a death places that come from Wikipedia, and what we want to do is geocode those places to extract their longitude and latitude. So what we do here is to install this library in Python called GeoPy, which does exactly that. So it's a very small library, so it shouldn't take long to do. We can import it, and in particular, the sub-library called geocoders, which we're going to be useful. And we will initialize it by saying, number one, you're going to be using Nominatim, which is the OpenStreetMap API. And number two, although it's a bit less important, we're going to give it a user agent thing so that the server of the geographical source knows who is asking what places. You can put whatever you want. It really does not matter. Okay. And then as a test, remember the example I gave you in the lecture. If you just simply copy and paste what you find on the cardboard and run this, it gives you the sort of standardized address in which city, in which state, in which country, and some geographical coordinates. And to extract just those coordinates, you can access the properties of the object with a dot, for example, latitude, or longitude, like that. Okay, because we're going to be doing this operation of think of a city and ask it to give us back the latitude and longitude, we might as well create a function that we're going to be calling many times. This is the standard programming practice. If you do something many times, don't copy and paste it, just create a function and call that function with different arguments. So let's define a function that is going to be called getCoordinateCity, and the function takes a city as an input, passes it as an argument to our geocoder engine, waits a bit, and this is quite important because otherwise the server over there is going to be overloaded and will prevent you from accessing the data. It's going to make the program crash. So we wait a tiny bit, just a tenth of a second here, and we want to get back the latitude and the longitude. And then what we do is we create a new column in our table that is going to be called birthplace lat, birthplace lon, and those are simply the latitude of the result for that city. It's a bit of a complicated structure. This is not a lecture or a course on how to manipulate pandas per se. So if you have a question, you might want to look at other resources or send me an email, of course. But the idea is that you're going to repeat this function for every city in your database. So we can do that. Mind you, this is going to take a bit of time because because of the amount of time we need to wait and getting the data back. So I think mistake. See, the program here was not quite happy because we didn't wait long enough, and the server is overloaded. Perhaps while this is running, we can discuss the optional question here. What would be a ways to optimize this function and make its running time much shorter? Did any one of you think of a solution for that? Could we restrict the search by requesting only in Europe? Yes, you could. That's one solution, and the details of that depend on which geocoder you use. However, what is long here, what is taking time, is not really where you're looking for, but how many times you're looking for it. So any other idea? That perhaps limit the number of times you do the querying. Well, a possibility, for example, would be, and this is especially useful in our cases when we've got many times Venice or many times Florence or Paris, that comes up a lot, etc., would be to get the list of cities that are mentioned and just compute them once. That way, if Paris appears 20 times, we only ask for the coordinate once and do not ask 20 times. Okay, so this has finished running. And as you can now see, we've managed to extract the longitude and latitude of each place. So we're very happy with this. So meaning we can replace in space our entry. Okay, we can convert this into a geographical database, which you can think of as simply a geographical version of the things we've been manipulating so far. So instead of using pandas, we're going to be using geopandas, but it's exactly the same thing. It's just very happy with geometries and geographies. And again, this is not a geopandas lecture, so not much time spent on this, except that it is possible to have geographical information system in Python that are very easy to manipulate. Okay, so this line here creates such a geographical table, a geodata frame, basically the same data frame, but with an extra column called geometry, which is going to be points at the birthplace, latitude and longitude. So we can look here, and as you can see, this column has many points in Europe. We might want to be interested in plotting them, and this is the final section, because we've created those tables, we have made them historical with dates. I mean, we have made them also spatial with positioning in space. But the point of that is, of course, we can try to then make some statistics, the sort of thing that you might be interested in, and that's why you're here, I presume. So just as a final section, there's a bit of examples on how you can get some statistics from those databases and how you can plot them. It's very, very simple. Maybe take a few minutes to look at that. To make it a bit more interesting, we will not just be looking at 15 entries or 14 entries, but I've taken a bigger sample of the Chini dataset. Basically, everything we've done so far, I've done for 30,000 artworks, and I've put you that subset on the Google Drive for you to play. So just click through the cells and see what it does. There's a question here from Sabine who asks, does it occur that sometimes same information can be found twice? If so, how do you solve it? What do you mean exactly? Do you mean that one entry is duplicated, or do you mean that it's got two possible values?
Yes, so I precise it was about the same entry that has been duplicated.
And is that entry duplicated in your original document, or
some yes, duplicated from the original documents, but also just like a ghost page, if I say so. Kind of.
Right. Well, it might appear that for some reason the pipeline duplicates things, but it is up to you to decide whether or not you want to keep it as such. You can detect for duplicates and decide to remove them if you're not interested in them. You can also decide to keep them if you want to keep those ghost pages, for example. It's really up to you.
Okay, thank you.
If there's no other question, I can just maybe go through the final part. So let's open this subset of the Chini Phototeca, which is again the sort of larger version of what we've been doing this last 3 sessions. We can turn this into this geographical table, this geodata frame, exactly using the same structure that I've put above. So we can click that. And just for you guys to see, this is what it looks like. So many artworks, about 37,000, with some geometries that describe where the person was born and where they were dead. Before I move on, I can answer Cecilia's question. You get an error because of the geocoding, and to solve that, you simply need to wait a bit longer between each query so you can change this parameter to, for example, 0.5 seconds like I've done. This is because the geocoder keeps asking again and again to OpenStreetMap for positions, and OpenStreetMap is like, no, that's too many times. Wait a bit. Okay, so we have this geographical table, and we can plot it by simply dot plot, and this is where the artists in our subset were born. Obviously, it's a bit hard to read for now, so what we might want to be doing is to add a background, a base map that shows us where the different countries are, etc. So this is the point of those 2 first lines, which download a very basic world map, which we're going to be restricting. This is the last 2 lines to Europe, so we can execute this. The first lines plot the world map in gray, and then we come and add onto that, as if adding an extra layer, our Gini pods. And this is what it looks like, representing the extent of our data set spatially. You might have read in the notes that this data set is not a random sample. I have chosen every entry for which the artist has died in Venice, and this plot then represents where those artists were born. So there is here at hand and readily available a form of geography of art, showing us what is the extent to which Venice attracts painters across Europe, at least seen through the examples of the Chini collection. We can get all other statistics from our table readily. For example, we can look at the temporal distribution of those artists. And to do this, we call our table, we say, oh, give me the author dates after death, and then plot this as an histogram. in the brackets, we specify how many bins we want. This is just for us to visualize a bit better. And then we add some title and labels, but that's purely cosmetic. And this is what the distribution looks like. So seen through the Chini corpus again, the artists that come and die in Venice are massively overrepresented in the 18th and 16th century. Something that can be, for example, the starting point of an inquiry. How would you get a similar histogram of birth years? Well, just copy and paste the code, and then replace death by birth, and perhaps for fanciness, we might want to make it red. And it looks like this. Okay. What about the number of artists, the number of artworks per artist? To do this, we can simply count the number of occurrences of each artist. So remember, this is our normalized spelling of an artist through the Getty. And this is how we do it. We value count it. And then I'm just showing you the top 20. Showing us that Francesco Guardi and Tintoretto and Veronese are the most popular, at least more frequently found artists dead in Venice in the Chini. But we can also look not just at artists, but also at collections. If you are interested in the dynamics of archive constructions, simply by changing this column from artist name to collection name. Okay, what about which artworks have been done by this artist? We, in this case, use the logic of our database to say, okay, find me or locate me the entries which have an artist named Visentini Antonio. And those are the 663 artworks that we have extracted from the Chini collection. You can also see the extent of at which the name alignment has worked. And if you look here in this column, this is the spread of spellings of this artist, sometimes in uppercase, sometimes with brackets, sometimes with extra things between parentheses, attributions, etc., etc. They're all matched correctly to our artist. Okay.
Maybe, Paul, just a last question from Cecilia in the chat, if you are capable to fix it.
Yes, I think we have. Is it? Yes, that has been discussed a few minutes ago.
Okay, I'm sorry.
Yeah, no problem.
Confused. Okay. And the conclusion. I'm sorry, up to you.
No, not at all.
Just for say this.
And then I don't know if some of you have attempted to do the mini project, or the tiny example of data analysis that combines all of the techniques we have seen and the data set. But I wanted to get the different histograms of deaths of artists for the top 5 collections, wondering if different collections are interested in different periods of history. I have prepared the code elsewhere. And this is what it looks like. So we can just comment this out. So if we look through the collections, the top 5, Böhm, then this is the Fondazione Giorgio Cini, this is Alinari, this is our Gernsheim we saw earlier, and Fiorentini, which are the top 5, as was shown here, ignoring, of course, the unknown collection. We can just loop through them, locate the artworks that correspond to that collection here, and then do the histogram of the other deaths, like here. So I'm just, plugging together the different pieces that we have mentioned. And then for cosmetic reasons, I'm simply adding a bit of color to it, depending on which collection we're looking at. And if we plot this, this is what it looks like. with the bomb collection being mostly interested in the 16th century, from the Tionecini being a bit more scattered, Alinari, again, 16th century, etc., etc. Okay. So this final and third session really was about leaving perhaps a bit the AI further back. We have seen in the first two how much we can leverage AI to do some visual extraction, some text extraction. This third session was really about the post-processing and the analysis steps of it, which are equally important and equally rich and perhaps equally free and open-ended. Bottom line being, anything you do when you use AI or any form of computation to study archives really depends on your scenario of inquiries. At every step, there are choices on what language you use, on what you do with exceptions, on what you do with the duplicates, for example, or errors, etc., etc. But we have seen that so many things are possible when things are properly formatted, and this goes from temporal analysis, geographical alignment, connection with external databases, etc., etc. Things that might be of interest to you for those of you working in historical archives and with similarly structured documents. Before I give the floor back to Isabella and all the very kind people at Giocini, is there any question on the general succession of courses, on the whole pipeline, on etc., etc.? By all means, please do ask them either now or later. I'd be very happy to answer them by email. Let me know.
Yeah, many thanks also for my side for this time. Unfortunately, there's no time to go further in detail of your researches, your use cases or applications. That's not. Yeah, it's a pity. So we really are interested in your feedback, and you're also in keep the contact with you. So please contact us so we can draw up eventually a mailing list for having you under the radar for further workshops or pedagogical activities. And we are still here. And many thanks to the Cini organization too. Many thanks to Irene and to Chiara Casarin for this hosting. So it was very nice and very good occasion of exchanging with your activities. Thank you.
Thank you, Isabella, and thank you, Paul. And this was really a very interesting course. We received very good feedback, so thanks again. And the recordings of the lectures will be published online on YouTube channel of Fondazione Giorgio Cini in a couple of weeks, and then also on the archive website. So yeah, if you have any other questions, you can just email us or Paul as well. And if there are no more questions, I think we can just say bye to everyone and hope to see you soon and to work for new projects together as well.